Insertion sort, a simple sorting algorithm that can be implemented in a few lines of code. At any iteration, the array is divided into two parts, a sorted part and an unsorted part. As the name suggests, we pick one element from the unsorted part and insert it at its correct position in the sorted part. For example, consider the following array. We start at index 1, all the elements before this index form our sorted part of the array. In this case, the sorted part only contains one element, 4. Now we pick the element at the current index and insert it at its correct position in the sorted part of the array. Let's store the element at the current index in a variable called key. Since 2 is smaller than 4, we bring 4 to index 1 and then put the value of key, which is 2, at index 0. Now the first two elements of this array are sorted. We then move to the next iteration. The element at index 2 is 7. We know that all the elements to the left of this index are sorted and 7 is greater than 4, the first element to its left. Therefore, 7 is already at its correct position and we do not need to move any elements around. In the next iteration, we find that once again the element is at its correct position, so let's move on. Now I is equal to 4 and key is 8. We compare key to the element at index I minus 1. In this case, that element, which is 9, is greater, so we move 9 to index 4. Then we compare key to the element at index I minus 2, which is 7. We find that 7 is less than key. Therefore, the correct position for our element is right between the 7 and the 9, and we set it there. The final iteration, I is 5 and our key is 6. We compare the key to the element at I minus 1, which happens to be greater than the key, so we move the element to index 5. Next, we compare it to the element at I minus 2, which also happens to be greater than our key. We move that element one index ahead to index 4. We now compare the key to the element at index I minus 3. This one's also greater, so we move it to index 3. Next, we compare the key to the element at index I minus 4. This is smaller, hence the correct position for 6 is between the 4 and the 7. We have now reached the end of the array and the sorting is complete. Next, we'll check out the pseudocode for this algorithm. But before that, let me tell you a short story. Once upon a time, there was a programmer. He was pretty good at making videos, so he thought of spreading programming knowledge on YouTube and making money. He made a few videos and then went to YouTube for monetization. But YouTube said,
"You can't get monetized before 1k subs."
Ladies and gentlemen, please, I request you to hit the subscribe button. I need you to sub. Now let's get to writing the pseudocode. Create an algorithm called Insertion Sort, which takes an array called ARR as its input. We create a loop to iterate from I equals 1 to the length of the array minus 1. Note that the starting index is 0. Inside the loop, we set key equal to the element at the ith position in the array, and we know that all elements before the ith index are sorted, so we set j equal to I minus 1. We create a while loop that runs until j is greater than or equal to 0 and key is smaller than ARRJ. If key is larger than ARRJ, we will place the key element at that location. Inside the loop, while both conditions are being met, we shift this element to the right by setting ARRJ plus 1 equals ARRJ and then decrement j. Once we exit the loop, we have either reached the beginning of the array or have found an element smaller than the key. So now we set ARRJ plus 1 equal to key. Note that the variable j was declared outside the while loop, so it maintains its value after the loop has ended. That's all for the pseudocode. If you liked the explanation or if you need any help, do leave a comment down below. Alright guys, in the next few videos we'll write the code for insertion sort in various programming languages. There will also be a link to the text-based tutorial and the full code in the description below. I highly encourage you to try programming this on your own in the programming language of your choice, and then, if you need to, check the tutorials. Come back for more sorting algorithms and DSA. Thanks for watching.